Uh, okay, so I just want to make first I want to make an administrative announcement. So for those of you who signed up for on the wait list, want to join this class, I have decided to add everybody, whatever. I have about 14 students who like to coming in. So I talked to the department. It's okay for we to have all the students, except some of us will be using either using your own laptop or you two of student can share one computer because we might not have. I mean, at the moment, it seems to me we have all the computer available for everybody. But I feel it's okay because a lot of us should be using your own laptop. So this is fine. Okay, then I'm going to just quickly review what we did last week, and then we're going to extend it into the rest of the curriculum. The first thing I emphasize a lot is a concept called addressable memory box. And this is very critical for understanding how a programming language like a C or C++ is going to interact with your hardware. And at this moment, the most important thing I like to interact is the memory. All right. So the first concept we kind of show you the idea called addressable memory means that it's a box, means that it has a fixed size, and it's a memory, and has a memory address. All right. And then we talk about the memory address. We went over the program, which I'm sorry, I've been really busy the past few days. So I haven't uploaded the code we used last week. I will try to do that as soon as possible. So it has this memory address is whether it's a 4-byte or it's 8-byte. So 4-byte memory address is what we call 32-bit computer. And 8-byte address is called 64-bit computer. And this is important. It's not just saying that you have two types of computer, but more important for a programmer to realize precisely what kind of platform you're running on. Are you running either 32-bit or 64-bit? So the trick is using this particular call called size off, this operator called size off. So I show you this over here. Let me try to let me show you the code. So you can see that on this lines of code. Let me take it out. Oh, here. This lines of code, especially this portion, size off, inside there is called void star. So void star is a generic pointer. We will get into what do I mean? A regular pointer and generic pointer. But at this moment, whatever pointer you have, the size should be the same. So size of a generic pointer means that how many memory bytes. So size of is basically telling you how many bytes for the data type or for the variable that's contained as the input of the size of operator. So size of void star literally means what's the size in terms of number of bytes about the pointer on your system. So for this computer, because this is a 64-bit computer, and therefore size off should be printed out as 8. So the printout for this particular line is 8-byte. Okay, that's the concept. Okay, let me get back to my. Okay, then we talk about, okay, this is something which is I mentioned, but I kind of forgot exactly the term. So I want to go over so later we'll be in sync in terms of this technology. So I use power of 2 a lot. By the way, in computer related technology, we don't use decimal. We use a binary. So it's a power of 2. So 2 to the 10 is 2 power to the 10. In other words, 2 to the 10 is K, kilobyte. And then 2 to the 20 is megabyte. 2 to the 30 is gigabyte. 2 to the 40 is terabyte. So that's the things we're familiar with. And 2 to the 50 is petabyte, right? That's already beyond most of us has a possibility to handle that much data. And then 2 to the 60 is called exabyte. Okay, it's called exabyte is E. And then 2 to the 70 is a zettabyte, is a ZB. Okay, so this is pretty much in our lifetime to deal with 2 to the 70. I mean, I believe there are more number after zettabyte, but that's good enough for this quarter. So from 2 to the 10 to 2 to the 70. And why is this important? Because I want to differentiate the difference between the memory addressability about a 32 computer and 64-bit computer. So if you're having let me see if I have a slide to actually talk about that. Yes, I do have this slides available over here. So for example, in this, I'm actually going to show you my computer, for example. My computer is a MacBook. You can see that in the figure on the right side of the slide. My computer, the computer I'm using right now, has 48 gigabytes of what we call memory. Okay. But the addressability of this, by the way, this computer is 64-bit. So 64-bit is 2 to the 64. And I want to tell you how big that is 2 to the 64 or 16 exabyte. Okay, 16 exabyte. By the way, this is just my guess, okay? If you add all the memory chips produced by all the company, and we put it together, I don't think we actually reach 1 exabyte. If you think about that, if all the memory chip has, you say it's a petabyte, I believe that. But if we have like a exabyte, I don't think human history, we haven't actually produced that. So you can think about a computer has 48 gigabyte, which is a 48 times 2 to the 30. That's the size of the memory this computer has. But the addressability of this memory address, 2 to the 64, is actually much, much bigger, is exponentially bigger than the computer really has. I'm actually going to explain this slide in more detail later, but at this moment, I want to review from last time why it's important to understand addressability and why it's important to understand how much more power we will get by using 64-bit computer instead of using 32-bit computer. So let me go back to this. I use an example, which I think is a good, valid example for us to understand the concept using USB file system, because a USB memory stick is what we use every day to copy the data. But there are 2 different file systems that's most popular on USB drive that's related to addressability. One is the most common, we call FAT32. FAT32 means that the file system is a FAT file system. By the way, the FAT file system was originally developed for Microsoft system. And then Microsoft developed something called NTFS, which is also file size is a lot bigger. FAT32 versus what we call EXT FAT. ext-FAT is a newer generation of FAT file system. I think FAT stands for flat table or something, file system. Okay, so the important thing is, okay, by the way, important thing I want to tell you to learning programming is that whatever we learn in class, whatever you do in programming, it's not just a theoretical concept. It's really related to the system or the computer or the phone we're using every day. So what I hope I can convey to you is whatever we learn, it must have touched some part of your life when you're using machine. So whenever you learn a concept from this class, I hope you can relate it to your phone or your system or whatever, your USB stick for this case. So if you're using, if you're a memory stick, last time I actually reformat my USB drive. If you format or erase your USB drive to be using FAT32, that means your addressability is only 2 to the 32. 2 to the 32 means 4 GB. So that put a limit on how big a file that you can have. So think about that. It's very interesting. You can try that experiment, which means that I can explain exactly why if you're using a FAT32, I'm sorry, the largest file you can have is 4 GB. So this was developed long time ago. By the way, FAT32 was developed probably 80s or 90s. At that time, if you have about, by the way, at that time, I want to actually give you some perspective. My computer, my hard drive is 1 terabyte. I remember I was so excited in 1988. I got my first computer. It was called IBM PC. I have a humongous hard disk. It was 20 megabyte. Okay, at that time, 20 megabyte was huge. Okay, you cannot imagine how technology moved from maybe 37 years ago until now. It was 20 megabyte was huge considered. Okay, so at that time, of course, I only deal with 20 megabyte. My hard drive is only 20 megabyte. At that time, if you tell me a file size 4 gigabyte, I thought this is huge. That's impossible. 4 gigabyte. Oh wow, that's great. Because I mean, the largest file I can possibly have on my hard disk is 20 megabyte. And you gave me a addressability of 4 gig. Of course, that's enough. But as technology move forward, now we're talking about 64-bit. We're talking about the limit of 64 exabyte. That's the limit. So that's why if you use ext-FAT, the largest file you can have is 64 exabyte. Okay, so the scale is good. For programmer, especially C programmer, you need to start thinking about this and thinking about the size of the data you're dealing with and things like that. Okay, so that's about memory address. The huge difference between a 64-bit computer and 32-bit. I mean, by the way, this is my personal experience. The first time I look at this number, oh, what's the big deal between 32-bit computer versus 64-bit computer? I said, only 32-bit difference. I mean, by the way, that's the way I think about that. But then when I try to apply this concept to my life, I realized, oh, 4 gigabyte is really too limited. When I want to copy any kind of application, especially I want to deal with a video file, then 4 gigabyte is just not enough for me to do that. Okay, that's the second concept we learned. Memory address. By the way, I feel a C programmer, or for the same reason, C++ programmer, we need to be very sensitive to memory. We need to be very sensitive to memory address. This kind of concept must be crystal clear in your mind about what's the system you're dealing with. Okay. Okay, the other concept we talk about is a network by-order and the host by-order, which I finally, for some reason, the slide was there, but I just couldn't find it last Thursday. So let me actually show you that this is the memory box, okay? And okay, I having two way of storing an integer one. Okay, so this one is the first 4 byte is 0, 0, 0, and then the fourth byte is 1. But the other way is like this: 0, 0, 0, 0, 1, and then 0, 0, 0. So there are two kind of representation for the same information. Essentially, I just want to represent an integer 1. And assuming this is a 32-bit integer, that's why you can count each byte is 8 bits. Okay, all right. So I want to tell you that remember we talked about two concepts. One is called little endian, and the other one is big endian. So with this two, which one is a little endian, which one is big endian? Anybody want to remember? If you remember what we did last week. Anybody want to answer? Do you remember what I said last week? If you don't answer the question, I'm going to do something horrible. I'm going to give you some chocolate. Did I say chocolate? Okay, this is Belgian chocolate. Okay, anybody want to enjoy a piece of chocolate by answering the question, even if it's a wrong answer? Oh, thank you. So what do you think? Yeah. Okay. Which one is big endian? Which one?
Little endian is you store the smallest one in the like the first one, so smallest in one, and then so on. If big endian, it's vice versa. It's the biggest in the first slot.
Okay.
Yeah.
So, okay, thank you.
Thank you.
Hope you enjoy your chocolate. Okay, if you want to have chocolate, we can have a multiple answer, of course. So let me actually tell you that this one, the least significant byte is the one with 1. Okay, that's the least significant byte. So the least significant byte come first. That's little endian. Okay, and this one, oh, this one is the most significant byte come first. So this one is big endian. Okay, so then I'm going to ask the following question. I mentioned this last time. I'm not sure anybody will remember this. What's the difference between network by order and host by order? What's the difference? You can Google it. What's the difference between network by order and host by order? Okay, great, thank you. Yeah, so the network by order is the order you're going to submit the information across the internet. That's defined by network protocol. That usually involve how you will interpret the information, because when I send information from the network, I have to send sequentially, right? One byte after the other. So there is a what we call the order. So for the network, is always go with big endian. Okay, so which means that the most significant byte is actually going to come out first. By the way, I want to show you this slide. Sorry. So I have a host versus network by order. So this is a more of a graphical representation. If you're looking at, assuming I want to send 1, 2, 3, 4, A, B, C, D, which is hexadecimal, 8 hexadecimal digit. I want to send that 32-bit information out. And you can see that the little endian, I'm actually going to send CD, which is the least significant byte. But while the big endian, I'm actually going to send the 1, 2, which is the most significant byte. So that's why I put it here. If you want to use network protocols such as TCP, UDP, IP, whatever, you're going to follow the big endian. But for the little endian, it depends. IBM computer used to be everything is a big endian, just like the network by order. But the Intel architecture, if you're using any kind of Intel architecture, including my computer, is actually a big endian. Okay, so let me do a little bit programming show over here. I hope I still have that computer around. Let me see. I cannot believe I have. Wait a minute. Where did I put my code? Oh, okay. I have a program I want to show you. This is called HBO, host by order. All right. So let's take a look at this small program. I can actually check whether this particular computer we're using, the host, because I said network, we always follow big endian, but some of the computer are follow the big endian, and some of this follow little endian. So I have to write a program to check my computer whether it's one way or the other. So you can see that I actually have an integer, which is I is 32-bit integer, and then I set to be 1. And then what I did is I put the address. The second line is I put the address of I into the pointer, a character pointer of C. So C is a pointer, is a character. So essentially, while C is a pointer, but the star C, which is the value that C is pointing to, is actually the most significant byte. I shouldn't say most significant, the first byte. Okay, the first byte, not most significant byte. So sorry. So if the first byte, star C, which is the first byte, if the star C, because it's the 1, so star, if the least significant guy, which is 1, then essentially the first byte is the least significant byte, which is equal to the value of 1. If you say if 1, then you print little endian. So that means this computer is little endian. Otherwise, is a big endian. Okay, so this I'll give you 10 seconds to just take a look at the program and see if you can understand. I want to go a little bit slower because this program might have a lot of elements you need to learn, understand. That this program will tell me, whoever asks you the program, whether you're running whether your computer, your host, is following little or big endian. Okay. Okay, I want you to take a look at the program. Any question about this program? I mean, you can ask me a few things. How do I represent pointer? How do I represent the first byte? And how do I represent any information? So this is a pretty small program, but it actually can do the job. Yes, please. Okay, sure. Thank you. I like you guys ask questions. I would like to encourage you. I know you know the answer. You just want to eat the chocolate, right? Okay, let me do this. Let me try to explain this line, right? Okay, so let me parse this line a little bit. I want to write it differently. Hold on. Okay, now I separate this program into two different lines to be, let us understand the two perspectives about this line. Okay, I have to get rid of one semicolon. So the first line is just a declaration. So what I declare, okay, remember I said this is my preference way of doing things. Remember I said I can actually remove the space from this side to the other. By the way, this program I download from Stack Overflow. If you do a Google on Stack Overflow to see how you can tell the little versus big endian on this program come up. So you can see that they actually put the star closer to the C instead of like what I did here. So what I'm doing here is this line is declaration. So declaration means that I declare C. This is, I would say, declaration. I declare C as a variable. And what's the data type of the variable is character star. And what's that data type? Is a pointer to a character. So this line is just declare C as a variable, which is a pointer type, which is pointing to the character. And I actually add this equal to null. That means I initialize this pointer to be null, to be 0, 0. So null equal to, let me tell you what null equal to 0x 0, 0, 0, 0, 0, 0, 0, 0. So basically I set the a byte to be, oh, actually in that case, this is a byte. Okay, I put all 0 into this pointer. Okay, that's one thing. All right, so let's parse the second part. So I is what? I is an integer. Okay, I is integer I declared earlier at this line. So I is an integer. What's mi? Anybody can tell me what's mi? Right, i's address, right? Who answered that? You want chocolate? You answer that, or who answer that? You already have chocolate? All right, if nobody claims, you can have that. Okay, all right. So mi is the address of the I. Remember, this is the whole concept of memory box. If I want to have an integer I have to find 4 bytes of memory that inside my memory address. By the way, today I'm going to telling you it's the memory of 48 gigabyte on my computer, but I don't believe I can do that. But Thursday, you will see that the memory is what? 64 exabyte. 1 4 byte out of 64 exabyte is going to use to store this integer I. And then this integer I is going to have address. In fact, the 4 bytes, so I have a 4 address. So mi is giving you the smallest address of that, the memory boxes that store that integer I. Okay, so mi is going to be it's a pointer to character, pointer to integer I. By the way, I want to tell you there is a why I have to do this, character star. This is called casting. Okay, can someone tell me what's the data type of mi? Can someone tell me what's the what? I heard something. Okay, let me just tell you because I'm almost done with my time. Okay, let me show you what's the type. The mi. Okay, so the data type of mi is actually integer star. So what's mi? Mi is a address of an integer. So remember I said address is the same as pointer. So essentially the data type is integer star. And can someone tell me what's the data type of C? C is character star, remember? So one of the pointer on the left-hand side is character star. And the pointer on the right-hand side is integer star. They're all address, but they're address of different type. If you don't do casting, the compiler might give you a warning saying that you try to assign some value from a different type. That's programming language, that's compiler. They try to tell you that you don't understand. You never take the course of Introduction to Computer Science 2, so you don't know that memory address is the same or different. So they will give you warning. So that's why you have to do this character star with parentheses in front of MI to do what we call casting. So casting is you don't have to understand what casting is, because in C++, casting is so complicated. I mean, right now you see casting is easy, but I can tell you casting is one of the most difficult concepts in C++, especially we talk about polymorphism. But this is a concept is casting. I have to do a casting in order to make sure the compiler won't complain what I'm doing. Okay, so that's this line. So essentially what you have is assign the address of the integer I into this pointer of character star C. Okay, so this C basically is a memory address of the first byte of the integer I. Okay, does that answer your question in the back? Is everything okay? I still have a question. Anybody else? Okay, by the way, this concept is hard because it's just not just learning programming language, but your thinking right now is actually thinking about to the level of bits and how would they be stored on your memory. Okay, that's actually a pretty challenging concept. So I kind of go a little bit slower, but it's important for you to understand. Any other questions regarding this small program to help you determine whether you're having a little endian, and big endian? Okay, all right, I'm going to move on. We will come back to a similar situation the rest of the semester, and don't worry about this. Okay, my job is to make sure you will eventually learn. All right, so I'm going back to, okay, so this is what we did. Okay, this particular slide essentially show you all the important concept we learned from last week, the first 3 hours. And I do want to say that you have your textbook, that the textbook, you should already have one from your Introduction to Computer Science 1 last semester. It's the same textbook. If you have the textbook, what I cover right now is partially related to chapter 7 of your textbook when we cover the pointer. But I do want to say two things. I might have a biased opinion about textbooks. I feel typically a textbook, they did not capture the most modern development of the language or the environment. And they usually focus more on the language perspective, not on the system perspective. So that's why I kind of like the book to learn the syntax of the language, C or C++. But when I talk about how this language interact with my system, then I feel the textbook didn't have enough to cover. So I prefer you follow my lecture. I will send you some link to Stack Overflow or some of the program example. I feel to learn those by reading the textbook is not enough. You have to write the program. From writing a program, you learn exactly what the language, how would they interact with the system. So you can see that I don't consider reading the textbook is mandatory. I only feel that it's a reference. If you really like to get some information related to the language part or look at some example, the textbook did a good job. Okay, so just hold on there. Okay, so I have about 6 minutes. Now I'm going to move on to the next topic that I'm going to cover this week. I'm going to start talking about operating system. Okay, so this is what we call a motherboard. This is a real system. There's a hardware system. You can see that in this hardware system, in this particular corner, oh, you have a CPU, and this one has a PCI bus. And the PCI bus allow you to plug in a NVIDIA GPU card, for example. But over here, you have what we call memory slot. So this memory slot is essentially for you to put in your memory module, which in my computer is put in just like a 48 gigabyte of memory. So this is the hardware we're dealing with. So your program need to learn how to interact with this hardware. So what is a program? A program is really you put down some software and it will manage and control your hardware. This could be a very powerful computer and could be a very simple computer, okay? And this is what the operating system looks like. So what is the operating system? Operating system, we typically follow this architecture. So on the lower end, that you have what we call hardware, your CPU, GPU, your memory, your hard disk, your DVD drive, your wireless communication, your camera, those are all what we call the device. So your hardware is essentially a motherboard connecting to various devices together. And then you have your application. Your application, you can think about your smartphone. Your smartphone has a smartphone hardware, but on top of your smartphone, you can have all kinds of application that you're using every day. So you can think about a system is essentially a bunch of application. They are sharing and utilizing the hardware beneath. Okay, so what is the operating system? So operating system is essentially provide a piece of software to allow the management for the hardware supporting all the application. I mean, why you need manage? Because if you only have one application, then you don't really need operating system, because application is the only application that needs the hardware 100%. It dominates, so you don't worry too much. I do want to say still you have a cases, even if you have one application, you still need to at least have some operating system concept. But most likely that your operating system is running multiple application. And multiple application means that all of them are going to share the memory. All of them are going to share the CPU. All of them are going to share your camera. All of them are going to share your input device. So how do you manage the sharing such that every application will be able to run smoothly under the hardware below the operating system? So that's the job of operating system. So now I'm going to show you one thing. This is something which is related to your computer. I mean, this is for every single. I want to show you this slide first before I jump to the program to end this class. Okay, I'm going to use this slide to represent very quickly. So this part is, I will call it operating system kernel. If I use the word kernel, you don't understand what it is, don't worry about that, okay? But in the what we call user space, you have multiple applications. Each application is sometimes we call a process, okay? So now, any typical computer, you have a multiple process running. Let me use the example about my computer, for example. If I do a PS, you can see that this is the process that's running on my computer right now. But this is really on the S Felix tool as a user. If I do PS minus EF, let me do a more or less. You can see that this is all the process that's running on my computer. So you can think about using the simple Unix command. If you have a terminal with a Linux or a Mac, you can type PS minus EF to see all the process that's actually running on my computer. So let me do one thing to be easily check how many process I have. I do a WC. So I totally on this small computer, I have a 7069 process running. I have a 700, almost 800 programs simultaneously running. And I have the other program called top. You can actually see the top, which is another way, top and PS. Usually when I want to see how many programs running on my computer, which computer using how much hardware, I'm using either both PS and top. And if you run top, you can see that the top is basically say how many percent of my CPU. So you can see 53% of my CPU on this computer is using for which application? Zoom, which is I'm using this record this lecture. And then you can see how much memory is using. Zoom is using physically about 1.1 gigabyte of my memory. And then it says how many the state is sleeping. I will explain to you sleeping and how much time it has been running. And this is what we call process ID, PID. Process ID is every single program that's running, and it has an ID for you to control. I can actually do a kill, which kill that process. Okay, so this give you some idea. I have you can see I totally have a 772 processes is running, and it has a 4,900 whatever threads that's actually running. Okay. So this is give you some basic concept about the operating system kernel is having a bunch of computer. In this case, I have about 770 processes. They are sharing the hardware, which is my MacBook, and the operating system, which is the Linux-based system or Unix-based system, is managing how the 770 processes or programs are sharing my computer hardware. Okay, I'm going to stop here. Any question at this moment? Okay, I will see you on Thursday. Thank you. Hold on 1 second.